But I think every session, especially the next 3 sessions, they're going to be a little heavy in a sense. I won't put emphasis on the coding as much as the concept. All the code is provided to you, and I also made a special function on the basic machine learning objects, so it makes your life easier. I don't really want to focus on the programming too much, but at least I'm providing you with all what you need. So if you really want to dive into programming, which I recommend, it's not required, but I strongly recommend because your life is going to be going in that direction, and you most likely will get stuck some point. I wanted also to emphasize, some people get confused between different kind of programming. The stuff that we use in machine learning, it really is a code for data scientists. When you write a software, it's really type different style of writing. For example, the way I developed the Academy City, it's more as a software engineering style of programming in Python. Totally different libraries. And when you do machine learning, you mostly use the libraries I mentioned before, Pandas, NumPy, scikit-learn, SciPy, those kind of typical libraries for machine learning. If you go into more advanced topics as deep learning, you have a beautiful library written by Google, came out the end of 2015, called TensorFlow, which is excellent library for deep learning. What the difference between machine learning and deep learning? It's machine learning is mostly using conventional algorithms for predictions, clustering, and all of that, and we talk about them. And deep learning is really when you deal with ton of data, okay? And that's really very advanced mathematics. Even in face recognition, the algorithm is very different than it used to be in the 2000 even, I would say. Convolution, it's a very advanced mathematics topic, not in the scope of this course. But it's really nice to know the difference. The difference is in deep learning, you have to use a lot of data, like big data, and machine learning usually reasonable size. Deep learning, you won't get anything unless you have a ton of data. Just imagine that you have face recognition and you have like 10,000 matrices, which you have to estimate all the parameters. There's no way unless you have millions of data. Machine learning, you don't really have to. In the chapter 2, which is really the main core of this course, I don't think with the background you guys have, we can do more than that. It's a beautiful chapter, by the way, that takes us from A to Z on a machine learning algorithm. Later on, if you want to read, all the book is wonderful. You can really do follow even with a self-study. In addition, I provide you with all the code. I organize the code in such a way that if you choose to dive into the code, you can start studying by yourself, definitely. You have all the components, most of the components you will need in the future in order to develop a machine learning study, okay? So let's start the next topic. Let's say, first of all, what we did last time. Last time, we talked about it, that we got a database. We used the StatLib repository about pricing in California, and we're trying to understand what drives the prices in different areas in the area of California. So, and we started the process. We mentioned all the steps that you have in a study, and we just got into get data, and then we start talking about a little bit visualizations. So let me just go quickly of what we did last time. Please, I would just move it a little bit to the right. Sometimes I might close it if I need more space on my computer, okay? But I can keep that one on for now. Okay. So we got the data, and in fact, I told you the beautiful part about the component that I made and the utilities, the basic one. For you, I recommend, you don't really have to go really deep inside. How does it do it? It's just to know, nice to know just how the save figure, it really does save the figure, the plotting right into the right place for that specific chapter. The same is about all the other, load Excel data. So if you download Excel and then you want to upload it, so you will be in the objects, so you can do that. You can, I do strongly recommend, you don't really have to, but it's well organized here that all the data, it's inside the object itself. And we today will talk about how do we take the data and we'll split it to training data and a test data. And then we talk about how we take both two and we separate what we call target column versus all the other columns. Meaning we try to understand the target variable, in this case is the prices in California of houses. And the other variables are proximity to the ocean, how many bedrooms are in the house, what the income of the people that live in the house. Those are all explanatory variables. So we'll be splitting them. And the beautiful part about these objects, it will do a lot of those stuff that we talk about automatically. But it's nice to familiarize yourself and later on just forget about the detail. That's what I usually do. After I finish writing any function here, I forget about it. I can't really remember all of it, but I know what it does. For example, split, train, and test, we will use it today. But if you look at it inside, there's a lot of detail. For a beginner, I will recommend you dive into it and try to study it. I won't require it in the exam, but I will do, at least why do we use a split train to test? That's a concept you need to know in machine learning. So this is the basic objects that has really almost everything we need in this course. So you don't really have to know the detail, but it's nice to. And then in the views, we have all the functions organized by chapters. We started last week on chapter 2, and we'll dive into some of the code I will show. The first thing we do in chapter 2, we inherit from first of all, we inherit algo 2 is inheriting from the basic algo. We create one and then we start working with. The first things we did last time, we called this function. How do we call it? We, in fact, have a web application. So when we go into Intro to Machine Learning, we go to chapter 2, and then the first one, bring the data. We looked at the data, we have several columns in the database. See how nice. In fact, that component, you just tell him which URL you want the data to come from. And in this case, in fact, I think it's downloading a zip file. You unzip it automatically and put the right Excel file into the right place. Then you read the data and put it in the data frame of Panda. Pandas we learned, we had a session and I uploaded another session for NumPy. I didn't want to spend the time on technical too much, so I just recorded a session and I strongly recommend you view that lecture. Here, the whole work is done for us automatically. We have a Panda data frame. We open it as a web application. By the way, you really should, by this time, kind of at least understand this code, which is very simple. In fact, after I'm getting the data from the algo data. It's all the data. This is the data frame. I show a lot of stuff here. We talked about them last time. The information, describe, give me all the statistics. But then I transfer some information to create a web page. It's not really part of this course, but it's something you should have studied, most likely you did. How do you create a web page? So whoever really wants to dive into it, it's all organized here nicely. So if you see here, it says get data.html. So if you look at that, it's right here under chapter 2, because this is automatically, it will pick it up right there. And if you double click on it, you will see it's such an extremely simple HTML. But I take advantage of software engineering. If you notice, there's some stuff you probably haven't studied. This command, for example, shows me all the data. So there's another language called Jinja that before it's rendering the HTML is able to take Panda data frame and convert it to HTML. In another word, if I have a table in data frame, okay, in Panda data frame, somebody already have written a code, which I don't really care how we did it. I just know how to use it. I take a data frame and it's automatically generate. It's like an HTML. So this small line, basically creating this image here. This is the data frame, just an HTML. I think this is really good to know that it exists. I'm not really required that you know for this class, but I think you are, as a data scientist, you better know that it exists. And when you really need it in real life, you can use it. I use the same trick as you saw in the code, just to present the other stuff we learned last time. Okay, this is where we have the counts of every types, and then the statistics we mentioned last time. Then we did last time also, we looked at the different attributes. Attributes means every column here, okay? So when we look at every column, we try to plot them, and that's what we kind of started last week, and look at the distribution of most of them, okay? We talked about that this one looks like a normal distribution, but it really isn't. I have a little peak here, If I assume that this is normal distribution, I probably will make a mistake in my analysis. Secondly, we notice that there is a huge line here, which means somebody probably chopped all the data there. Let me make it bigger, by the way. Yeah, somebody have chopped the numbers and said, everything's about 50, I will call it like 50 years old. That's really destroying part of the data, and most likely you will remove those one, they most likely will destroy your conclusions. Some things is here. Another phenomena we saw, it's something like this kind of, that's what we call tail-heavy distribution. It means it looks like normal here, but then on the right, it's kind of moving to the right. That's tail-heavy to the right. Could be to the other side, by the way, okay? This one is also a classical one. And usually the way to handle this and convert it to more reasonable data, you take the log of the numbers. So you take the log of every number here, it will make it looks more like a normal distribution. And then it will make the analysis much better. We talk about data scaling and standardizations today, but immediately when you see something like that, even before you scale it, you might take the log of a data, and that's very common. I wouldn't mention it if it's not common type of data that you will see in real life. Stock prices, by the way, sometimes have a heavy tail. Many variables do have this kind of distribution. This one I probably will throw away, unfortunately, or I will just give a call to the guy that prepared the data and I ask him or her to send me their real data and don't chop the data. Another thing to look at about populations along the, along the longitude, which really means that I have a lot of people living something in the middle of California, something next to the ocean. And as we saw in the picture, we'll see it one more time, that's probably telling me when I go east to west, probably the population size is different. That's really what it means, basically. So is that distribution important? Most likely not, unless I'm analyzing location. I will talk about it also later on. This is giving me a little, see, all of them really, this one also have a heavy tail. This one, most of them. So taking a log will be a natural things to do for these kind of cases. Okay, beautiful. That's what we did last time. We looked at the image. mind you. And by the way, really plotting something like that, it's very easy. To make your life easier even, I took away a lot of the variables that you need for plotting, and I added a function in this object. It's called plot. Should be somewhere here. The plot basically takes, the variable, the x variable, the y variable, that's the x and the y's. This one, the s, is a variable that gives me the size of the bubble. Here we're using the population for that. The other one is scaling. So if I have a population in billions or millions, then I might want to scale it by 100, so I shrink the numbers so the bubbles won't be too long, too big. So that's only kind of a scaling factor that I added there. This one is which variables do I want to use for the color. So if I look at the pictures again, the C, it's another variable that is the prices themselves. So as the number is higher, the price is higher, the reddish will be the color here. On the other hand, the bigger the population in a specific district, the bigger the bubble. This is an elegant way of, it's one concept in programming, it's called encapsulation. I don't really care about the detail anymore. I just want to know which variables do I need to put. There is those 4 variables: X, Y, size, and the color that I want. The rest is really more detailed, convenient for a course like that. When you create that image, you want to save it, so you can give it a name. You can give it a name, okay? And you can tell him if it's going to be PNG or that's going to be a JPEG, but that's detail on saving that one into your hard disk, and later on you'll be able to read it automatically. This is a really nice functions to have, and all the detail which you have also in the book, but you really don't have to spend your time unnecessary, unless you really want to be a machine learning programmer, okay? But that's a nice plotting function to plot something like that. So if you need to do a plotting like that, it would be really nice maybe to give you a project to do the same things for, let's say, the houses in the East Coast of the US. It would be really nice. I'll see if I can handle that and give you it as an exercise. And then you don't really have to do much. Just get the data and use that plot function, automatically will generate the whole things. Okay, good. So let's go to the next things. It's data exploration. And we start talking about, okay, we have, the district, several districts in California. And then I say, I'm going to do a study. And we're going to learn in the study that we need to split the data to a training data and a test data. Later on, I will explain why. Now, usually you can take 80% of the data to study the algorithm, and then you test the algorithm on the test data. So that's why we split all the data sample to 2 subsamples, one for the training and one for the testing. Now, when you do that, naturally you say, okay, let's take randomly 80% of the rows, those will be for the training, and 20% for the test. And that sounds reasonable, and then you'll find out that really doing that, you might don't get a representative sample. For example, we have very few houses that are so cheap, okay? And if you took random sample, you might don't get any of them. And then your sample will be biased. In the sense, let's say I took 80%, and all of them fall in the 80%. None of them was in the test. So my test sample will not replicate the structure of the population. So many times what we do not, I put a line under it, do not use random sampling to split the samples. We do what is known as stratified sampling. In another word, I made sure that when I sample my database, I take 80% of these low-level houses, I take 80% of these, each segment of the housing prices, or what we know, we usually use the concept of beans. We take all the houses, we see the median income for all the districts, and we organize them from people with the lowest income up to the people with the highest income. Here it's classical to do, it's like 5 segments, and then I try to sample records or districts based on the incomes, but I make sure that I will take 80% from each bin, and I will take 20% from each bin. I will not take randomly 80% because I might get biased data, and I might even get to a point which is even worse. They don't even have any record of those ones in the 20%. Okay, that will be really a problematic thing. Is that clear, by the way? This is not an easy topic to handle. I wrote all the code for it, by the way, so you can, when I click here and can you see the image here? That means that that one was running here. You can see the whole code. I put a lot of descriptions here so you can follow along. I think this is an excellent, excellent way of studying whoever really want to dive into the code. All the code is provided to you right here. That was for getting the data. And now we just talk, this is for the taking the attribute pictures that we just talked about a second ago. Okay, and now we're talking about, this is the scatter image, if you really want to know how I implemented to make the picture. This is this one, you have it right here. This is the code. And if you want to see the fourth one, which is like what we're talking about right now, it's how do I create those bins and make a picture. By the way, I kind of, again, encapsulated the whole things you need to do bins right in one line. So you don't really have it, you can change the numbers here, you get a different spread of the bins. But basically what it does, it takes the sample, brackets to 2, 20% will be for the testing. I use the field of median income to create those bins because they have several variables, but I'm more focused on the median income. We'll see in a minute because median income is the most important variable to understand prices of housing prices in California. The rest are, those are the bins. I put it like 5 or 6, and anything's above 6, it's infinity. So those are the bins, and I give them labels from 1 to 5. So between 0 to 1.5 is the first bin, and then this is the second, etc. And from 6 to infinity, meaning every price, any income will be the last bin. Okay, so I have 5 bins. This is automatically will create those bins, and then I will be able to print it. It's also printed automatically, and I can view it right here. So this one, it's really the code for how to create that one. Whoever interested, this one becomes to be an easy. This one we have seen already. This is another functions of Panda. You just tell him the variables you want, and it will create kind of scatter matrix. What does that mean? I can see, by the way, those one are just histogram of the same variable. So this one, median housing value, that's the histogram, similar to what we saw for the housing, for what we saw in the previous one. So that's, we already have focused. This is interesting to show what is the relationship between the median income and the mean housing value. Here we see there is some positive relationship. The more the median income in that district high, the higher are the houses in that district, which makes sense, which common not only in California, quite common around the world. rich people live in bigger houses, basically. That's really what it says. Is it one-to-one? No, because that's why we have a lot of points all over the places. But in general speaking, there is a correlations between those two. And in a minute, we'll talk about correlation. Okay, so there is a link. So looking at the picture already gave me something. There's also here some, but to a lower extent. There is a link between total rooms to the mean housing value, but it's not really that clean as this one relatively. So not exactly, there is correlation, but it's lower than I can say about this one. We'll see when we calculate the correlation, this one between those two variables, the correlation is not as high as between this one and this one. Here we barely see any, yeah? Okay, we barely see any, okay? So what about this one? If we look at the housing median versus the total rooms, okay? Is the edge of the house is older, okay? Does that mean that we will have less rooms? So new houses you can say here, the newer houses are bigger usually. That's really more or less, but not, it's also not really that strong correlation to some extent, I would say. That's really a nice visualizations of the data before you get into more scientific way of analyzing this data. Then if you see something like that, you would like to zoom in. So when you see this one, you just create image by itself. And then new phenomena is revealed. If you have good eyes, you see, first of all, prices were chopped at 500. Okay, but if you see even closer, you see, it seems like there's some, I can't even explain why do I see another line here. Who knows who did something to this data before he sent it to me. So I might even consider when I see a line like that, okay, I might even remove them because I really want to know, generally speaking, the link between income to housing prices, and those might destroy my conclusions because I really don't know. It seems like phenomenon. I might run it, learn the algorithm, and do it two ways, one with and one without. And if there is a big difference, I might remove those data and try to understand what that phenomena is. I definitely, most definitely, will remove those ones because those ones are going to destroy my conclusions because somebody manually destroyed all the data that should have been on up here. So this is really destroyed data and should be removed. See how basic plotting, it's excellent just for understanding. Some things we see here, by the way, no question, there's probably some phenomena here that I cannot explain just by looking at the picture. Okay, so that's what we call like explanatory or visualizations of the data. And before I start diving into more scientific way to analyze the data. Let me take a pause and ask if somebody has any questions or everything is clear. Everybody happy? Victoria? Daniel?
Yeah.
Happy?
Very happy.
Good. Good. So, Moria, can I continue?
Yep, you can.
Okay, everything is clear?
Yep.
So if I put this picture and this picture on the exam, and I will ask which one have a higher correlation, everybody will know the answer. Which one would have a higher correlation? This one or this one? Anybody?
Is it the one on the left?
On the left, that's right. That's right. Will it be one? You know, correlation between -1 to 1.
No,
That will be
not
one.
one.
Will it be positive or negative?
It's a positive correlation.
Positive, because it's when this goes up, this one goes up too. And if it's the other way around, it will be negative correlations, okay? And I have a tricky question I put in the tech exam. You know, take a test just to help you to study the material. I added some questions and I'm going to add more questions as we go along. And I'm going to emphasize that point about negative and positive correlations, explaining phenomena. So that's why I kind of issue that one. But that's kind of a question I might ask, okay? Basically.
Amos,
Yeah, go ahead.
sorry if you already said this, but are the like small tests that you put on Academy City, are they mandatory, like part of our grade, or it's for us to study?
You got to know me by now, don't you? Everything I do, it's to help you to know as much as possible. You choose if you want to do it. I think it's childish that I have to monitor what you do. By the way, I already know every click you make. Academy City have an engine below, okay, that I can tell you what every student have done during the whole semester. I never really use it because I'm not a babysitter. You know what I mean? It's really for you.
Okay, that's what I thought.
If you ask me, if I were a student, I definitely would do it, honestly. And I remember myself, I think, well, my English will never be as good as yours, okay? And when I was a student, my English was terrible. I barely could write my name. And I remember as a student, I was reading only from English books. And everybody took the books in Hebrew. And I knew how important it is. So I was killing myself knowing that's the right way to study. Even it was not really that easy at the time. It's much easier for me now, of course. But I think the right things is try to go over those questions. Definitely will prepare you for the exam, help you to study too. Many times I take, let's take an example. I really like, I'm happy you asked that question. Okay, I give you an exam of a type of a question I put. Okay, question that I put, and really was the purpose of it is really just to help you and lead you to read the book. So if you look at those ones, let's go into chapter 2. And this is the book, the chapter, yeah? And then I put a question here. You know, the objective of putting this, this is mine. I need to log as a student. But anyway, you can see that. This is the way I prepare the questions, by the way. It's a special, you know, I write here, and then you see it's in a nicer way, okay? So here we go. I took this picture and I asked you a question about it. Did I really, I'm not gonna put a question like that exactly. I might, you know, but it helps you to follow reading, it encourages you. That's the objective of all those. Here we go, we're gonna talk about correlation. And I put a nice question here, which will help you to study, okay? And some part don't really exist in the book. You know, I'm just putting it in the question that really help you to notice stuff that are not emphasized enough in the chapter, okay? And that's just a few examples, and I'm feeding more questions for you guys. Okay, so I'm glad you already asked. It's intended to help you to study and be ready for the exam so you don't have to kill yourself a couple of days before the exam and don't sleep 2 days, which happen many times, yeah.
Thank you.
You know? So anyway, let's move on to the next issue. And if you notice, I really follow basically the chapter as we go along. This is just a review to remind you. We talked about we need we have the whole process. We talked about the whole process. We choose a model, we train it, and then we test it. And the way we test it, we need a performance measure, okay? And here we talked about last time about 2 types of performance measures. One is the mean square error, okay, which is very popular. The other one is the absolute mean square. And this is really just taking, here it's just taking the difference. Doesn't matter positive or negative, we turn it to a positive, we sum it up and take the average. The other one, we square every number, okay, and then add them up, take the average, and then take the square root. That's 2 measures. The higher the number, it means that my prediction is worse. And I will emphasize that more when we take a real case, okay? Those 2 stuff we talked last time. Here I just mentioned that what we did in the, that you have all those functions in the objects. We did all of that stuff. So we basically got to here, and that's what we just talked about a second ago. Now, this is really also talking about what I just mentioned, the stratified sampling. And this is really, if you want to go and see the code, you're more than welcome. If you don't, you know there is one function in my objects that does the work. This table just showing you that when you do stratified sampling, it's automatically, almost by definition, the sample that you take for the training subsample and for the test subsample will be very close to the overall. But if you take randomly, believe it or not, there is differences, and those differences might be really crucial, especially for the low level. Here it's really, it seems like not a big one, but already can destroy your conclusions. So most of the time, when there is a variable which is really difference between the population of that variables, okay, then we do a stratified sampling and not random sampling. Then we talked about how to present it visually, okay, and here you have all the steps which I kind of put in one function. My function plot basically does the whole things here. And if you want to know really how we did it, you're more than welcome. Read the book. This is excellent. You know, there is a function alpha. I embedded the alpha inside my function. In fact, I put alpha 0.4, okay? It's really just re-emphasizing the places that has a higher density, okay? After I'm happy with 0.4, I don't need to do the whole step. I just made one function and beautifully immediately give me exactly what I want, okay? And here I mentioned, please see the code. If you really want to know how I implemented it as one function, you're more than welcome. What the beautiful part of doing it. I don't really have to rewrite. If I want to do, as I said, for the East or the Eastern coast, and I want to do same plot, I can use a database for the Eastern housing prices and do the same plot on the right side. And by the way, you can go Google, you can get an image of almost any map, very similar to the one of California that you have in the code here, and you can implement the same stuff. Okay, beautiful. Let's move on. Let's talk about correlation. And I want to warn you about several stuff. Let me make it bigger so you can see it better. What is correlation? Correlation objective is studied in statistics. And by the way, when you use Panda data frame, this is a Panda data frame, you just write that correlation and create the whole correlation. You can be more specific. You can tell him, do a correlation, okay? Okay, after you do the correlation, just give me just one part. And here I'm really only interested, only the correlation of the housing values with all the rest. So I don't really want to see all the metrics, because when you do a correlation of set of variables, you know, you'll get a matrix. And I'm not interested in the matrix. I'm only interested in the column of all the variables with the housing value. Anybody can tell me, why do I get 1 for the first one? That's a complete correlation. Anybody can guess why?
Because
Why is it? It must be 1, yeah? Can be something else.
it's just the median. I don't know. Maybe I'm wrong.
When do you get correlation exactly 1? When you
And
do
the value matches the prediction.
Say again?
Never mind. I think
When it's
I'm wrong.
exactly the same?
Exactly. I'm using exactly the same variable. I'm doing median housing on a median housing. So it's the same variable, and the correlation of one variable with itself is always 1. Okay? What about if I did a correlation of the housing value with another variable, which is the same numbers, but I put a minus next to it? What will be the correlation then?
0?
No. Remember, I'm
Negative
taking
1.
the same variable, I'm putting a minus.
Negative 1.
A -1, exactly right.
Oh.
-1, it means when one is going up, the other one going down. That's really what it means, isn't it? If I put a minus,
Yeah.
the other is a 1. That's pretty cool. So this is just like kind of a complete one. It means I'm really using the same variable, basically. Or more correctly to say, because it will remove scaling, it means that it's really the same proportion, I should really say. Any two variables that has the same proportion will give me correlation of 1, or if it's exact, the negative of it will give me a correlation of -1. Anything will be in between. So if I'm looking at those numbers and the median income, it's 0.68, almost 0.69, what does that mean? Is that high correlation? Is that low correlation? And if I look at all, go ahead.
I was just gonna say, it seems pretty good to me.
Yeah, relative to the other, definitely. It is high. That's pretty good. So if I want to explain the median housing value in California, probably the best variable that explains it, it's the income of that district. The higher is the income at that district, I can say the higher will be probably the housing value at that district. On the other hand, if I look at how many rooms I have in the house, is that perfect or is that good explanations for the median house? Not really. It does have some, like almost 14%, but it's not as good as the income. So here it's organized, going from the highest, which is trivial. It doesn't really give me anything, but from the income, and it goes down, it's organized. The one that really almost have no explanation power is the total bedrooms that I have in the house. So number of rooms in the house can explain better than the total bedrooms, okay, versus general rooms. But now is the tricky question, okay? Let's see who will get it right. If I compare the latitude, which is really giving me how close I am to the ocean, and I look at the housing price, there is a negative correlation. Is that right? -14. Will you say this is have a better or a worse? Here my question, I will repeat it twice. Is the latitude as explanatory variable, it has more power to explain the housing value more or less than the total bedrooms? The total bedrooms is almost 5%, and this is 14% negative. Which one do you think has more power to explain?
You said the latitude was how far it is from the coast, from the
Let's
sea?
take one. Who is let's give the lady first. Go ahead.
No, that was from my microphone.
Oh. So which one do you think? The latitude will be or the total bedrooms? Which one has a more power to explain the prices? This is 5% positive. This is 14% negative. What do you say?
The bedrooms?
Why? Because it's positive?
Yeah.
Okay, let me help you out. Let's I give you another variable. Let's take another example. Make it more exciting. Let's say you want to invest in the stock exchange. Okay, you find IBM, and you have another stock that every day the IBM stock goes up, the other stock a day before went down. One more time. You look at the stock of IBM, and you realize that over time, every time stock of IBM went up, another stock, let's just make it up, okay, Amos stock, a day before it went down. Can you develop a strategy to make a lot of money knowing that information?
Yes, just because it's a negative correlation doesn't mean it's weak.
Exactly. So in fact, if you see a 100% correlation with the example I gave, if every time that Amos stock went down, IBM went up the following day, that's perfect variable that I would love to have.
So it's actually the absolute value of the correlation that matters.
Beautiful. So we can sum up. The higher is the absolute value of the correlation, the higher is the explanation power of that variable. Okay? So positive doesn't have more than the negative. It's just the direction. Negative and positive means are the opposite direction or are going in the same direction. But what I'm really interested in is to know how to explain the value of the housing. So positive direction says if one is high, the other one is also high. The negative will say if this is low, that's really a good indication that the price goes up. So if the latitude was for a -1, that will be, I don't really need any variable. That will be a perfect one to use to estimate the housing price. Okay? That's just the point. By the way, it's all written here in the book, but I put a questions in the take a test. One more point about, this is really like, theoretically, you should come with that knowledge from your statistics course. Okay? Correlation by itself might be misleading because when we measure correlation, or at least what is known as a Pearson correlation, it's not really telling the whole story. It's a linear correlation. Let's take another example. No doubt that if my data was like that, there is a relationship. It's not linear. So in this example, if you calculate the correlation the way we do, you will get 0. Still, if I use non-linear relationship, there is a relationship between the dots. Okay? So this is really the most interesting. This one is really, obviously there's a relationship between the X and the Y, but if I calculate the correlation, I will get a straight line. Because in a linear way, it's like kind of, this is really the middle. That's where I can put a line that most accurately will represent. The same thing is here. Here, I have the same shape up and down. Definitely there is a relationship between the dots. So if I have an X like here, I would say it's probably 0. If I have X here, I say the Y might be this one or this one. So I might don't say exactly which one it is, but at least I know some relationship between the X and the Y. But if I do a calculation of correlation, I will get 0, okay? So be careful. Getting 0 not always means there is no relationship, okay? And that's why we plot the data. That's why we start this section or this chapter by talking about visualization. When I look at the picture, we did see, we don't have any strange phenomena that there is a relationship. It's so linear will not be too bad, okay? So that's really, you can read it here. Okay, let's say here we went over that one. I showed that one and we talked about it. So I'll move on and we move and combinations. What does that mean? We saw the correlation here in this data that, you know, bedrooms don't really exactly explain much. And we have total rooms that does explain more. But maybe I can create new variables or ratios. How about number of, you know, the ratio between total rooms to total bedrooms? Maybe that will be a better explanatory than just taking each one of them separately. Then I can add another variable. That means generating more variables out of the data. Many times you do that. In fact, in sophisticated algorithms, you know, there's some packages that allow you to generate really weird, theoretically looks originally weird, many types of variables that might explain better than each one of them by itself. But the obvious one, maybe how about how many household per room? Maybe that can explain better. You know, if I take the household, number of household divided by number of bedrooms or numbers of rooms, maybe that will be a better explanation. So combination means take the original data and try to generate other variables. And here we used some more. For example, we used bedrooms per room. We took the number of bedrooms, we divide by number of rooms, we got a new variable. Okay, that's the code. Whoever wants to really see the data. By the way, this is really simple. In data frame, this is a data frame of Panda. I take this column and divide it by that column, I get a new variable. That's really very simple Panda operation, okay? So I got another 3 variables. So my list of variables increased by 3. I run the same command of correlation. I look at that correlation and bingo, I'm getting, wow, bedroom per room, in fact, have almost 26%. That's probably better than my other variables, okay? That's better than just looking at the household, looking at only the total bedrooms or the rooms per house. By the way, rooms per household gives me better than it was before if I look only at the rooms or the household by itself. But definitely, bedrooms per room, that's pretty interesting. Means,
That makes sense.
which makes sense too. You're right. You're right. If you think about it, if I have more bedrooms per room, okay, it's negative. It means really rich people. How many bedrooms do they need? Usually you don't have a lot of them. But if you have a lot of rooms, that means you are probably rich. And I won't be surprised to see, if I look at the whole matrix, that there will be a correlation between this one and the income. Because I would expect the more rich the person, he would have more rooms relative to bedrooms, okay? Which make a lot of sense. And that's pretty interesting that you start creating out of the raw data, new data that can explain better the housing price. And that's what we do in machine learning. We haven't started talking about algorithm yet, but we're talking about data preparation, data processing. Many people kind of skip that stage, and I think they're doing a crime to themselves. Because if you don't do that, you'll get bad results, and then you don't know really why. Doing that exercise before you get to the algorithm, it's really essential. I think I mentioned that last time. I was looking at a paper of one of my colleagues tried to publish, and I looked at the data. She hired some statistician, and she told me, can you look at the data? And I did look at the data, and I said, you know, that statistician have done a terrible job. We're going to talk about imputation in a minute, and he did something called imputation, but it should have removed some data of a missing data. So by me looking at the data itself visually, I spotted it. Otherwise, you couldn't spot it. And skipping that stage, she got totally different conclusion than she should. So she definitely threw the whole things and started all over. Okay, but I'm going to talk about all those topics in a minute. In fact, today I will get to that. Missing data, imputation, very important issues that you have to deal with the data. Okay, so why do we want? One thing is really here is advice to write functions, and that's exactly what I did for you guys. Many of those functions that we talked about, I combined them into one object. And those really, I really like those because they are so clean, easy to use, and the hell with what it's inside because I just want to use them. I spend the time when I needed to know, we'll talk about pipeline, we'll talk about other things, but the plot is really one of my favorite out of all of them because it's so clean. Just give the variables, bingo, I get a picture. I don't really care how it's being done. You're going to be a manager. I strongly recommend you go through the process so one day you will have computer scientists working for you. You'll get the most out of them because you will know they can do it. And then you just tell them, make me an objects like that so I can use it over and over in many of the studies. So in here in the book, as you see, it encourages you to do that so you can use your code over and over without having to dive into everything inside again and again. By the way, even the stratification, I just wrote a note here that I encapsulated, and you have one function that does it automatically and take the sample as a stratified and make sure that the subsample has the same distribution as the whole sample, okay? Now let's talk about cleaning the data, okay? And let's talk about missing data. If you recall, originally, when we looked at the data and we wrote info, and we used, in the info we saw it, and we saw it in the count, when we counted how many data points we have in each column, we noticed that, I think it was the bedrooms, yeah, the total bedrooms had some missing data. Then we said, what we're going to do is that. By the way, I'm going to skip this one and because it's too important, I'm going to come back to it. And I will come back to it when we kind of use those vocabulary. It will make more sense than just me going over that now, which will not make sense to you now, but I will give example and then I will come back and go over this part of the scikit-learn design. Okay, this is very important note, by the way, but it won't make a lot of sense to you before you can see really good examples, and then we go over it again. Okay, so we're going to deal with missing data. What am I going to do with this missing data in the column of total bedrooms? Anybody has an idea? What will you do when you have some rows and you don't have the data for it? So, and you want to use that row, but you can't really use it because it has some missing data. What will you do? Because you don't really want to lose the information in the other column of that row. Will you just delete that row? What do you do? Anybody has an idea? You can guess, don't worry.
Maybe you could estimate
I was a
somehow.
student, I wouldn't know myself either. Just guess.
Maybe you could estimate somehow.
Take it. Yeah, that's what I was.
What will you do?
Ben said to estimate, estimate basically off of something else.
Yeah, give me a simple one. You're right, you're absolutely right. By the way, this is a good one. It's a really
So
nice
let's say,
phrase. Now, hold a second, you phrased it nicely. You phrased it in the right way. It's you're going to estimate that number from other things. And there's really more sophisticated algorithms we're not going to use in this course, but it's definitely the right way to see it. But let's say you have some information about people. Let's take another example, okay? I want to know if a student is a boy or a girl. I have all the information about the people, but some people, girls or boys, are missing, okay, the eye color. Okay? I don't know if girls has more blue colors, eyes, or boys. I never really asked that question. But let's say I'm missing that information, I have everything else. It won't be a bad idea to say that I would take the average color of the girls, and put it there for girls, and take the average color for boys and put it for the boys. I probably will not be too badly destroying my data, or at least I kind of put something in average, so at least that information would be like the average subsample of boys and girls, but I'm keeping all the other information that otherwise, if I will erase the row, I will lose. So many times when you have missing data, rule of thumb many people use, it's to take the median and plug the median for that column in the places you are missing. Okay, I usually in real life use much more sophisticated algorithm, which is really like running regressions with other, since the computer does all the work automatically, usually give you a better result. For this course, saying that you use the median, it's pretty good. You can use the average, you can use the median, you can use, I don't know. But, and there's a lot of functions in scikit-learn library that does all of that automatically for you. So you don't really have to be lazy or write anything, so just use a different component. But as a beginner, using a median, it's not a bad idea. So here what we do is we look at this one. If I really want to delete, by the way, this is just for programming purposes. If you want to delete all the rows that has a missing data, that's the way you do it. If you want to drop the whole column, that's option 2, which I wouldn't recommend. Both of those I wouldn't recommend. The third one is really take the median and plug it in wherever you have a missing data. By the way, the in place means after you run it, the housing automatically being updated. But that's more detailed technical issue that how to write the same things. So basically fill NA means fill it with the median, and the median I calculated in the row before, okay? The nice thing is they don't really have to do it manually. There's a component called imputer that's filling missing data. It's called imputation. That's the professional name. And the beautiful part is that this library comes with a component. By the way, by now you need to know what this line means in Python. From the library, sub-library that called pre-processing of the scikit-learn, it's from this library, there is a component, there is a class. Imputer is a class, by the way. So bring that class and make me a favor, create an instance of that class, and this instance can have different strategies. Means if I'm going to use it, should I use the median? Should I use the average? So I can tell him mean. I will take the mean to use. And then after I use it, I can just implement it to the variable that here is the imputation. But I'm going to say it one more time because I want to emphasize especially the word feed, the function feed. Here we have a class. We create an instance of the class. When we create, this is really we're using the constructor of that class. All of those stuff I went over in the beginning of the course. So somebody have written a class for me, and it did me a big favor. I'm using that class to create an instance of that class. And when I'm building it, I'm using the constructor. And one of the variables of the constructor is a strategy. And I'm telling him, when you're building up that instance for me, I want the parameters to be median. So now I have an instance that I'm going to use, okay? Now, let me jump right to here. I will come back to this one in a second. For us, this is a data frame. This is our data. So I want to implement to use median to fill in missing data. And the way I do it, I will take that instance, and that instance has a function called feed. And I implement that function on the database that I want to fill up with the missing data with the median. One more time, I'm creating an instance of imputer. I take that imputer and I'm telling him, use the median to fill missing data. I take that imputer and it has a function called feed, and he implements it to all the missing data with the median of that column. So if I had two columns that had missing data, it would fill the data in those columns with the medians of the data. Now, why did I repeat myself several times? And I mentioned the feed because many of the components of the scikit-learn library are in this style. You create an instance, you put the parameters, and you use a function called feed. It will do the job for you on a data frame. We'll see some more examples of that. So a feed function, it's part of usually those components that do the works for you, and you use the feed. We'll see some more examples of other components, okay? Here, the only thing is really, I just remove one, the drop function. It's only removing one column because this is categorical data, if you recall. Categorical means, if we go back to our example here into the data, if you notice, this is not a number, okay? So I can't really use that imputer on it. There's a different type of imputer, which we're gonna see in a minute, okay? So if I had some missing data here, I would use that something else, okay? But for a numeric, the imputer, it's a good one if you want to use a simple like mean, median, or average, or whatever, okay? So that's why we remove that one so we can implement the imputer on all the other columns. Okay, let's move on. So that's beautiful, it's nice. I don't really have to do all this work by hand. I don't really care. I can even forget that it exists even. I just know that I can use the imputer. After I have the imputer, I implement it on the database, it will do the job for me. This one is just to show you that both methods will give you the same result. I will skip it. We're going to use auto imputer and don't waste our time. Okay. Then, by the way, it's generally speaking, okay, the imputer basically transformed the data. Meaning, what does it mean transform? Wherever there was a missing data, it kind of filled up the data. And many times, the imputer will get a data frame, but it will return a NumPy array. And we know there's two different elements. Both of them look like a table, but they're really not the same. And NumPy array, it's really designed for speeding, okay? So many times if I want to continue, I just convert whatever I got back into a data frame. But that's more technical issue. I'm not going to hunt you on that, definitely not. But I strongly recommend to be aware to that. And if you want to be really a good data scientist, strongly recommend you understand that command. It's basically taking the same X that came out and turn it to a data frame. As I turn it to a data frame, NumPy does not have names to the column. Therefore, I'm renaming the columns to whatever it was in the original data frame. Okay, that's detail, and I want to really go more into that. What about handling text or categorical attributes? That's really another topic. Just think about it. Let's look at the data again. You have a lot of words here. Computers don't like letters. They take a lot of space. If you remember in the business intelligence class, we said the less text you use, the better it is, the faster it will work. And we would like to turn every category into a number. Moreover, and that's really very important point, let's say I have about 10 or 11 categories, and I can, or I don't know really, I don't remember how many there are, but I can look it up. It's probably down here. Yeah, I think there's only 1, 2, 3, 4, 5 categories. Now, if I want to change every category here into a number, the algorithm might get confused. You will say, okay, if this is 0, 1, 2, 3, 4, probably 0 is close to 1. And you make a lot of conclusion that there really aren't, you know, because the ocean and island are further in the meaning than ocean and near ocean. Near ocean is probably similar to 1 hour from the ocean to a near ocean, probably more related, even if I will give it a number 0, and this one I will give number 4. And that's, the algorithm might get confused. So one way to overcome it, something known as a one-hot encoding. That's pretty important. Let me open Excel for a second, and I'll explain that method. It looks very primitive, but it's beautiful when you dive into how the algorithm works. Let's say I have I have those 5 categories. I'll just, for simplicity, name them A, B, C, D, and E. Fair enough? I have 5 categories. I would like to give this one the number 0, or let's say even 1, just so I won't get confused here, 2, 3, 4, and 5. Fair enough? And this one the computer might think, well, you know, in alphabetic, it's sure that A is closer to B, but what the meaning of B, it might be totally different than the meaning of A. And there's a lot of, in deep learning, how can I represent every letter in a vector of numbers? And then the meaning of B might be totally different than A, and B might be even closer to P, depending where in the sentence it's sitting there. So to avoid conclusion that 1 is close to 2, many times what we do, we turn the 1 to have the number 1 in the beginning, and then the other 4, I would put 0. That means this is representation. Now the 1 has no meaning. Okay, it's only the location. The number 2, I will start with a 0 and I will put a 1 in the second one. That's representing the second one. Is that right? And the same we'll do the other ones. I'll put a 0 here, a 0 here, and I'll put 1, it's like the location. So this way, the algorithm will get it as if I have 5 variables, but at least I'm not confusing them by, sorry, this should be 0. That's a 1. That's called hot encoding, one hot encoding. Very popular in machine learning. And the beautiful part, and thank God, we have a component that somebody was nice to create that can take these variables and turn it immediately to 5 variables. Now, if I had more categories, if I have 10 categories, I probably would have 10 columns here. So just imagine if you had 100 categories, you'll have a matrix that's full of zeros and only 1 somewhere, okay? And that would be a waste of computer space. And in minutes, I will get to that. There is what is known as a sparse matrix, just to save spaces on the computer. Recommended if you do heavy duty stuff with a lot of categories. Otherwise, you can just ignore it. Okay, so now we understand what is a one hot encoding. The another thing is to know that the library comes with a component known as one hot encoder, and all what I have to do, I create an instance, very similar to what we did with the other component in the computer, and then I just use the feed. If you notice, there is a feed command, but there is also transformer. The reason is, let me explain the difference between feed and transformer. And 90% you will use feed and transformer together. What does that mean? If you notice in the computer, we had to create the instance, and we told him already the median, okay? Here we use the feed, okay, to use the data to feed inside the database. So that's really generated the statistics for that he calculated. When he used the feed, he calculated the median. And I went a little too fast, and I kind of skipped the second part of the computer. Right after the feed, I calculate all the medians for every column. Then I have to implement it on the data set. Since it's the same data set, I could have done it immediately by doing it together. I could have combined the feed and the transform, so it will learn, it will calculate the median without using the missing data, and then implement it at the same time on the same database. So that's why many times we will have, using a component, we'll use feed underscore transform, it will do both actions together. It will calculate, in this example, the median, and will implement it immediately. Here I did it 2 steps, and I don't really have to, I can do it in 1 step. If we go back to here, in the encoder, okay, is learning the encoding, is learning that there are 5 categories. He takes the column, and he understands the encoding, and I want to use feed and transform. So learn the categories that there are 5, turn them to 1 to 5, and implement the encoding to turn it to like zeros and 1, wherever it has to be, okay? So that does all 2 jobs together. Here it's this is a little hard for a naive people, and this is a little hard, but I will give it a try. When we have this column, this is, by the way, a column we created above. This is the column of the category. If you see it here, this is really, we took the category column, and that category, we turn it to from 0 to 4. That's, we use the encoder to turn it to 0 to 4. Now, if you notice, this is an array of 1 dimension, and this encoder requires 2 dimensions. To remind you, when we studied Python, I emphasized the difference between a list and a data that is a matrix of 2 dimensions. For example, if I have a row of numbers, let's go back to the Excel. Let's say I'm just making it up of some numbers. Okay, this is like a list. Okay, in Python, this one I can represent by putting let me just shrink that a little bit. I can present it as a bracket, square bracket, and put those numbers 1, 4, 3, 5, 6, 8, and 7. Close. This is 1 dimension array. But if I want it as a 2 dimension, like I have columns and row, meaning I have 1 row and several columns, I will have to turn it to something like that. It will be exactly the same. When you print array of 2 dimensions, it will be exactly the same, but 2 brackets. Now, this is really 1 row, is still 1 row, but represented as 2 dimensions. It means I have 1 row and several columns. This is just says a row. It's really hard to explain. It's very complex. If I had 2 rows, I will usually have it something like that. Let me take this one even down here. You will have another row here. I'm just copying the same things. I will change the numbers in a second. Now I have an array of 2 rows and the same numbers of columns. I will just change some numbers here. So we will know it's not the same row. This is an array of 2 rows and how many columns we have? 1, 2, 3, 4, 5, 6, 7. And 7 columns. This is 2-dimensional array. This is not a 2-dimensional, it's 1-dimension array. To turn this one into 2-dimensional, although it's 1 row, this is the way to write it. Okay? So this one, the same things, but represented as a 2-dimensions array. This one, 1-dimension array. This one, the same data, but I can have 2 indexes. Okay? The first index will have only 0, yeah, because I have only 1 row. In this example, I have 2 rows, so I have 2 dimensions, but the rows index will have 0 and 1 because I have 2 rows. So many times it look to you odd. Why do I need to transfer this one to this? In fact, in the example that we're looking at, we try to take this one to convert it to something else. And this is really what it does. That code a little annoying, you know, especially to a beginner. What this code is really doing, it's something like that. Really nice to see it at least once, and it's repeating itself so many times. The code really does something like that. It's turning it to 1 dimension, but as a column. Okay? And etc. Honestly, for a beginner, this is really hard, but as time goes by, you get better and better. You realize it's not the end of the world. You get the idea. What do we get here? We really do have a column, but this is a column, it's 2-dimensional. It has 7 rows, 1 column. It is not 1 array, it's a 2-dimensional array of a column. This one is just 1 dimension, so I don't really care if it's a column or a rows, okay? But this is very important. This one, if I want to multiply it by a matrix on the left side, it will know how to multiply. If I take a matrix, multiply it by this one, it will not know what to do because it is expecting 2 dimensions. And many times you can get stuck for nothing. So knowing that is crucial, okay? I'm not going to test you on that in the exam, really. It won't be fair. But I will be a criminal if I won't at least tell you that it exists. Extremely important if you want to be a data scientist. And this is really a little complex. This one says to the data frame, you know what? Reshape 1 dimension to 2 dimension. And you know how I would like you to do it? In the column, give me only 1 column. How many rows I should have when I put a -1, you decide. In another word, in my example, I'm giving him this one, and I'm telling him, please take that list, turn it to 2-dimension array, but I want only 1 column. The only way you can do it is just doing it this way. This is 1 column, and he decide how many rows. I can give it to you as an exercise. You know, I should really probably delete one number, and then you can do it as an exercise. I'm not going to ask you in the exam. It won't be really fair or be too hard for a beginner. But if I took that example, if I took this one, and I gave you the same command here, and I wrote a 2 here, and I left the -1, what will be the result of that? The result of that will be that I have a 2 columns array. Let me copy it, will be easier for me. You will do something like that. You will say, well, you want 2 columns, I will give you 2 columns, no problem. You will put that number here. Fair enough? Now I have an array of 2 by 3. I didn't tell him, I didn't give him the 3, I didn't give him the 3 rows, but I did tell him I want 2 columns. So he will do it that way. A little confusing, it's a convention in Python using NumPy. So reshape is extremely important function in Python for machine learning. And that's really crucial to understand. Very easy when you understand it. It means take the 1 row, turn it to 1 array of 2 dimensions. And then it does all the work on turning that one immediately to this one. The beautiful part of it is that you can really even skip all this reading, jump right to this, because the scikit-learn has another component, does all the work together immediately. You give him a variable, this is a variable, a column, and he immediately transform, feed and transform, and immediately will give you that one. So I would recommend to read it, but you can, after you read it and you understand what it does, just the hell with it. And just go jump immediately, know that there's a component, does all the work for me. I'm putting a column, and it will give me an array according to the number of categories. All the rows immediately will give me a new column. Questions, guys, before we end? We have 1 more minute. I don't want to kill you. Hello? I lost some of you.
No, everything's good. Thank you, Amos.
Yeah, Moria.
I says sorry. She says sorry that she wasn't here. She had work and she'll watch the videos, and I feel fabulous.
Okay. Please don't step behind. You know, I will write it, I will send an email probably, but please, it's accumulating. It's not easy stuff. I try to make it as easy as I can, but as you can tell, it can get easily complicated. So don't step behind, and please take the test for yourself so you make sure you read the chapter, okay? We'll move on from here on, okay? And we continue on transformation. I'm going to dedicate another 2 sessions, which is the core of this course, on this chapter. So by the end of next 2 sessions will be by the end of this chapter. I think it's give you a really nice overview of what is a machine learning project. Okay? Thank you, guys.
Bye, Amos.
Bye,
Thanks,
guys.
Amos.
Thank you, guys. Have a good one.
You too.